Let's again look at a function defined as an integral. So we have big f of x is equal to the integral from a to x, small f of t dt. Right? So now we know by the fundamental theorem that for x bigger than a, this big F just has derivative small f. Now what about x less than a? Right. So now in this case the fundamental theorem doesn't apply. Right. But we can manipulate things in such a way that the theorem does apply. Right. So what do? Well, let's make a substitution. Right. And we're going to make a very simple substitution. We're going to put u equals to minus t. Right, so then du dt is minus 1. Alright? And if t equals a, then u is minus a. If t is x, then u is minus x. Right. So notice now that minus x is bigger than minus a. Right. So then using this substitution, we can write our function as integral minus a to minus x f of minus u du, and of course a minus 1 there, because the u dt is minus 1. Right? So you see in this case, we can now evaluate the derivative. Right. Remember, if we put g of x as integral from minus a to x f of minus u du, right, then by the fundamental theorem, its derivative would just be f of minus x. Right. But now, big F of x is minus g of minus x. Right. So, the derivative of big F would be minus the derivative of g of minus x times the derivative of minus x. Right. Just using the chain rule. So this would be minus f of, well, now instead of an x here, we need a minus x, so that would be minus x. And the derivative of minus x is minus 1. Right, so you see this minus and that one cancel. So still we get f of x. Okay. So this shows, and even for x less than a, this function is differentiable, right? And its derivative is still small f of x. Right. So this extends this fundamental theorem to values of x less than a.